Hello everyone, welcome back to Algo Daily. In this particular video, we are discussing Leetcode daily challenge. We are discussing in this problem counting words with a given prefix. So in this problem, we have to given a string words, array of string words and their prefix, and a string of prefix, which is the prefix we need to check. This prefix we need to check into our array of words. So we need to identify how many words in the array, okay, this is our array of words. How many words in array start with their prefix? Let's suppose we have their string is first start, this is our end, this is our st, okay, this is our string, and we need to find the prefix is equal to, let's suppose, st. So here this prefix is also present in here and here, so we need to calculate their count. Okay, so now let's discuss their example test case for better understanding. So first we have this example: pay attention, practice and attend. Okay, and prefix is also given is at. So step by step we check here, and first the value of the string is here pay, and this prefix is at, so we check with at pay. So this at is not present on their prefix value as pay, so this is not a valid count, so we directly return 0 for this. So let me track these values. Okay, so here our count is equal to 0, so the count again is equal to 0. Okay, so the next iteration we have here attention, and here we have the prefix of at. So at is present on their prefix, so this value is matched by their prefix and their words value, so the count is equal to 1. And so next word we have here practice. Practice is not the same prefix we have to given here, so this value is not changed, or the count is not changed, so the count remains same. And next we have here attend. Attend is a prefix value of their words, and so that's why the count is equal to 2. So the last count we have here is 2, so the answer is equal to 2. And same thing for this, if we have no any other count and their prefix values, so we directly return 0. And their simple code approach for this problem, we directly check with their values and their positions. So first we have to run their loop. Let's suppose we have int I is equal to 0, I less than this, let this words dot size, and this is plus I. And after this we have directly a simple if condition for this: if words of I dot find of prefix is equal to 0, then we directly count their values. Because of we are getting their values here. So this is a simple brute force approach. So now let's discuss their try approach for better understanding and their clear explanation for that. Okay, so here we have the code of try. So first we have to discuss their constraint basically. Okay, so here we have to given less than is equal to 100. So this means the array words will have at least one word, and this one word, and at least most of the words are less than is equal to 100. Okay, so this we have to given here, and the size of their words is small enough in single row, O of n form. Okay, so we have to efficiently check their values, and so now we have to discuss their try approach So first, one second. So the purpose of their structure, the children of 26, we have to each node can have up to 26 childrens, up to 26 childrens on for each letter of their alphabet. Okay, so the alphabet count of we have to declare here, and this count is to track their how many words pass through his node, which is useful for prefix counting. Okay, this is for prefix counting, and now this for loop we have to use this 26 time we have to running this loop, and this children of I is equal to null. This initialize all child pointers to null as no children is as no children is exist. So that's why we are using initially null. And then next we have here count is equal to 0 to initialize the count 2 is equal to 0 for no words are passing through this node. Okay, and after, so now the main logic of this code is we have to use a prefix tree. Okay, sorry, here prefix tree, and this root is equal to new node. This initialize the root node of the prefix tree of their root node. Okay, and why we are using this? The root is starting point of the prefix tree, the root of their prefix tree, and after it does not represent any character. So that's why this is the entry point of the tree. So that's why we are using root is equal to new node. And so the add method function, one second. So the void add method function is using for add a word to the prefix tree. So that's why we are using this method, and the node star current is equal to root. This start at the root node, and after this we have to iterate their loop, and this loop for each character or each word we are iterating here, and this index convert the character C to its corresponding index. Okay, to its corresponding index. So that's why we are using index here, and this if condition we are using for if there is no node for the current so the if there is no node, okay, there is no node for the character at index. Okay, so that's why we are using this, and after this condition we directly create a new node of a character. So this is a simple approach for to check their values on their prefix, and after this we have to add there. Okay, so in last we have current is equal to current to the children index. So here that we have to move to the child node, and we directly count their values. Okay, so I hope you understand this add logic, and after this we have here the get prefix count. This get prefix count, the use of this get prefix count to traversing the prefix tree, and after the given prefix and return we have to count how many last node of the prefix are present that. So here we have to start at the root node, and we have to iterate their loop for their prefix value, and this is our index, and the same condition we have performing before. So here the same condition we have performing, and after this we have to move their current to child node, and directly we have to count, we have to current to into count. So this return the count of words passing through through the last node of the prefix. So that's why we are using this. And the last this is our main function. This main function we are create a instance of the prefix tree, and for each word we are iterate a loop of a prefix tree, and after this we have to add their add function we have to use here of their words, and directly we have to return the query of the tree, sorry, this prefix tree to count the words with the given value, So I hope you understand the logic of this prefix tree and this add function and get prefix count. We have to directly call this prefix count. And so now let's discuss their time and space complexity. So the first we have to calculate their trie. This trie is the time complexity of trie is O of n into k, because of where this n is the number of words, and this k is the average length of words. Okay. And the prefix query we have also calculating there. The prefix query is O of m. M is the length of prefix here, and so the total time complexity of that code is O of n into k plus m. So this is our total time complexity. So now let's discuss their space complexity. The space complexity of this is the node we have to declare. So the node is representing with 26. So this is O of 26, you can say, and the total nodes depend on their unique prefix. So the value of that is O of n into k, same as their time complexity. So that's why O of n into k. So the mathematical solution of this is we have to use I is equal to 1 to n ki. We have to using this for achieving this one. So the total space complexity of that code is O of n into k, and the space complexity is also is O of n into k plus m. Okay. So I hope one thing is this makes the trie efficient for the solution by prefix based queries. So that's why we are using prefix and trie approach for that question. So I hope you understand the video and the logic behind that code. So thank you everyone, thank you so much.